SolidWorks Simulation, Lecture 8, Part 2, Transient Thermal Analysis. Now, in the last example, we talked about steady state thermal analysis, and we have defined the procedure to be steady state. Now, we'll change into transient state and run the procedure to, for example, 1,200 seconds with step size of 60 seconds. And the initial temperature will be defined later. Okay. Now, this is a transient thermal analysis, so we need to define the initial temperature by selecting temperature, initial temperature, on not the surfaces, but the body, the whole body, inside or outside, on all the elements, all the node points. So it is important that I choose the body instead of surface. That means the internal node points will also defined, and the value will be 25 degrees Celsius. So this is the initial condition. It is very important that you click on the initial temperature, not the temperature. The initial temperature, that it is a temperature of the structure of the heat sink at the time 0, and the unit will be Celsius. It is easier to read, and the initial temperature will be 25 degrees. So now I have already defined the initial temperature, and I'll deselect this item. So now I have initial temperature, and also I have defined the power generation to be 28 watts on the lower surface. And also I have defined the convection condition, and also it is a stagnant air, still air, and with 25 degrees temperature, ambient temperature of 25 degrees. So now I will go ahead and calculate the procedure. And remember that there are 20 steps to run, so it takes a little bit time to calculate. Now, after I finish with the calculation, I'll probe the same spot here, this spot, and I'll let it calculate the time profile for the point. And this is the time profile for the point. Actually, you can see from this profile that the system had not reached a steady state when the time goes to 1,200 seconds. So I need to extend the time. So now I'll change the properties and change the time to, for example, 2,000 seconds, or even 3,000 seconds. Okay, and I'll make sure the system will reach a steady state that I can compare with the formal example. In the last example, we know that the temperature here at time of infinity reached 152 degrees Celsius. So now we run the system for 3,000 seconds, and now I'll probe this point and let it draw a time profile for the temperature here. Now you can see from this profile that when time goes to infinity, the temperature will go will go to 152 degrees. And this is exactly the temperature for steady state condition. So you can see here that for the same spot, the same point here, the same point right here, in steady state condition, it calculates the temperature of the point when the time goes to infinity and the system becomes homogeneous. And this is the transient state. The temperature of the point rises from 25 degrees at time 0 to 152 degrees after it is about 800 seconds. So this is how the transient thermodynamics effect is. So the temperature will change through the process, and it will reach thermal equilibrium when the time goes large enough, and the temperature will approach that in steady state analysis.